Welcome back, YouTube fam, to the Madhouse. We're in part 2 of our knife making expedition, and today I'm wiring up the motor to the motor for the 2x72 grinder to the VFD. So I'll show you what I've got and how far I've gone. I've actually started it without you, but it's easy enough to explain what I've done, so I'll do that, and hopefully we'll get this together today. That's the plan. I'll show you what I've done so far, okay? And it might help somebody out. This is from the Dan Comau, I believe that's how you pronounce his name is. His 2x72 Sayber grinder design, which is on YouTube. If you search for that under Sayber, Sayber, I've converted mine to metric, obviously, but I can't convert the bolts and the motor to metric, so they're obviously UNC. So I'll give you the sizes for them as well, okay? But I'll show you what I've done so far. Okay, welcome to the mess. This is some of the things that you'll need. A decent set of side cutters. These are CKs, which are pretty good, industry standard. You'll obviously need some screwdrivers. That's a small flathead. We've got a Phillips as well over here. These are for crimping on ends if you need them, or for cutting wire. Not those ones actually. I'll put them aside. That's just misleading. These are my cable strippers, and this is for the connectors, for the forked connectors from my plug to the VFD. Okay, you'll need these to crimp them on properly. Use the middle one at the end there, and I'll show you. These are the things that I'm talking about. Little fork connectors. You could actually get away without using these if you wanted to. I just wanted mine to look tidy, if I'm honest. So let's start with the inverter, shall we? The inverter, this is the second inverter I had. The first one I bought was not IP66. There's IP66 and IP20. IP20 isn't dust proof, IP66 is. So this should stop any metal filings or whatever getting inside here, shorting it out and turning this into paperweight in no time. So if you want that, get an IP66. They are quite a bit dearer, but by the time you get an IP20 and you box it in with the proper box, and then you buy the remote controller for the speed dial and all the rest of it, you're as cheap just buying this. This cost me around about 350 quid, which is a fair hit, to be honest, for something that's just a hobby. But it's a cry once situation. With that, you get these two rubber plugs at the bottom. There's 4 ports in this metal plate, and you only need 2 of them. So the other 2 get blocked off with these rubber bungs. The easiest way to do it is to unscrew the metal plate and then take it out and then pull the bungs. They're like a cone shape. I'll show you because I just put this on top. You can see they're a cone shape there, but you have to pull it through so that the lips on the inside. See if I can get a decent shot. You can see there's a little lip there where it comes through the metal. You need that lip to be shown to seal it properly. And you can also see that I've added 2 20mm glands, these are called, and these will dust proof your cables going in. As you tighten this part, there's a bit in there that seals up around the cable so your cable's tight and it won't move. Okay, these weren't in the kit with the inverter. I had to go and buy these, so they're not much. They're a couple of quid, I think, at a Screwfix or Tool Station or wherever you want to go. So that's that. This is the inverter. Like I say, the model number of the inverter is, it's an Invertec ODE3 120070 1F1B, and it's a 1.5 kilowatt inverter. Okay, so this is just the faceplate. It unscrews. There's a screw each side. Take that off, and then you get in here. These ports at the top, these are for external controls. I won't be using them because I'm just using it as a grinder. But if you had like a remote keypad to work this with, you would end up wiring it into some of these ports, and you'd have to look at the wiring diagram to find out which ones. There's a wiring diagram. It came with the motor and the instructions. This is it here. It's pretty comprehensive, to be fair, and it tells you what goes where. This is for a 240 supply, and the other one is for a 3-phase supply. In the 3-phase supply, you'll have a third plug here. See if I can get a better picture of it. See where my finger is? In fact, I'll just point it out. This one here, if you get a 3-phase supply, you'll have another cable, another wire, should I say, that goes in here. Okay, this is for like your normal 13 amp plug socket. It goes into this part here. So the first one is your live. The second one's it's down as live 2, but it's actually the neutral, which would be the blue one. The one on the left would be the brown. And this one here is your earth. Now, there's also earths over here. This is the out from the inverter to the motor. There's a couple of earth points here. I'm presuming that these are on a bus bar, that all the earths are connected, because this earth needs to be earthed back to the source, if you like. And then you've got 3 ports here. One of them is U, one of them is V, the third one's W. And this is them here in the actual machine, yeah. That's your U, V and W there. So this is going from the inverter to the motor, and this is what's coming in from the plug that you plug into the wall, okay? So for the plug that you plug into the wall, I will show you what I've done. Because this is 2.5mm cable that I've used a heavy duty plug so that it all fits in there, because it's quite a tight squeeze. And on the other end, as you can see, I've crimped on these forked connectors. So the forked connectors will go through that hole in the bottom, and they'll connect up, like I say, live, neutral, and the earth is there. One of these 2 screws here, they're both earths, and there's also another 2 earths over here, yeah? So I'll put the earth from the plug in there, and the earth from the machine in there. I'm not sure if that's clear enough for you, but this one here is for the earth from the machine, from the motor, should I say. This one here is the earth from the plug. You just unscrew these with a small screwdriver, and then they slot in to these ports here. You can see this one's got the 3-phase blocked off, because this inverter is not for a 3-phase supply, it's for a 240 supply only. Okay, hope that makes sense. And like I say, these, don't worry about them too much unless you're putting in controls. So that's the inverter. They've got a good reputation, these Invertec ones, to be honest. And the way it works is fairly simple. You've got this is your switch on. Obviously turn that, switch it on. This is your speed dial controller. And this is for the direction of travel of your belt on your grinder. So obviously to the right's forward, to the left's backward. If you find that it's the other way round, what you need to do is to change out the U and the V. So put the V in the U and the U in the V. Cables from the motor, that is. However, I don't think that I need to do that. This is for your on is the green one, obviously. Off is the red one. This is for reducing the speed, increasing the speed, or it's possibly for going through the menus. I'm not sure how, because this one's got a dial, if that also does the speed, or if that's just for navigating your way through the menu. This is for selecting in your menu. You need to set these up before you use them. It's not just a case of wiring it up and plugging it in and going. You have to set up the parameters of the inverter before you use it. Okay, so that's your inverter, and this is the motor that I got It's a Iron Horse Premium Efficiency motor from America. Cost a bloody fortune. It was about 350 quid as well, believe it or not. And it's got a 5/8 of an inch output shaft, whereas most of the British motors have got 24mm. And it's also got UNC bolts that hold it into the frame. Now these UNC bolts are 3/8 with 16. I think that's threads per inch or whatever, and they're an inch long. So they'll probably just about bottom out. So I've got a 10mm frame on my grinder that'll be like here, if you like. And this will tighten down on it. Okay, so that's how the motor fixes to the grinder via that faceplate. Now then, the windings in the motor. Let's just get into that. What I'll do is I'll turn the motor around off camera and I'll show you what I've done. I've put another 20mm gland here. This is for the cables coming from the inverter to the motor. Okay, and then I'll explain to you which ones we're connecting up to what. Okay, just give me a second. Now, most British motors do not have this situation here with just all the wires coming out of it. There's usually like a board in here with screw-in connectors, and you'll also have like metal connections between the screw-in connectors, and that'll determine whether it's wired up as delta or star. Okay, this one doesn't have that. It does, however, have a wiring schematic on the actual plate of the motor. This is where it gives you all the information about the motor. Just go through it. This is the one that I would be using because I need to get 3,500 RPM out of it. Okay, so I'll be running it at 60 hertz, which will give me 1.5 horsepower. The volts, it gives you an option of 230 or 460. Obviously, we'll be using 230 because the British supply is 230. It's 230. Well, it's actually 240, but it's within the parameters. And the amps are 3.961 on this setting. You'll need to take a note of this because when you set up your inverter, you need to set the amp limit. Because if you don't set the amp limit on your settings and it goes past 3.961 or whatever it was, where is it? Yeah, 3.961, then your motor will give a nice big puff of smoke and die on the spot because you'll obviously be giving it more amperage than it can handle, should I say. SF, I have no idea what that means, to be honest. Or that. What else have we got? Frames, the 56C, that determines which kind of sort of frame size and mount you have. TEFC, that's totally enclosed, fan cooled. As you can see, there's a fan inside it to cool the motor, and there's also a filter in there. You need to hoover that out every now and again. You can see phase 3, which is indicating it's a 3-phase motor. Duty continuous. Code H, I don't know what that means. It's IP43, which will be the weather protection, I presume, on it. What it's rated at. Designation B, no idea what that means, or that. So there you go. You've got two options here. You've got your low voltage and your high voltage. The motor comes from the factory wired for high voltage. Okay, I'll say wired. The wires are twisted together for high voltage. However, you need low voltage. So these are the cables, as you can see, and they're all labelled T1 to T9. What's that one there? T8, T2. So, as you can see there, T2 and T8 are going into a 3-way port Wago 220 connector. 221. It's a Wago 3-way port, okay? So all these cables are connected. So the first two ports are obviously the wiring coming from the motor, and the third port will be the wiring, the cable that comes from the inverter. Okay, so let's just get back to this for a second. You can see here it's got T1 and T7, the blue and the brown, that's line 1, so they need to go together. Again, we've done that with the Wagos, same idea. Okay, there's the blue and the brown, I think it is. So that's the one that's referring to. Next up, we've got T2 and T8, which is the white and the red. That's your line 2. And then next up, we've got T3 and T9, which is line 3. Now that leaves you 3 loose cables, which aren't connected to anything. However, what you must do is terminate them to an insulated connection. So what I have done is I've used another Wago connector and I've just terminated them to that. And what I'll do is, I mean, this is insulated anyway, but I'll just stick some insulation tape over it to be doubly sure. But they must be connected together. You can't terminate them separately. These 3 are all connected, yeah? So that means this cable's connected to this cable is connected to the other cable. Okay, you can't just terminate that one separately or terminate that one separately or terminate that one. All 3 of these must be together or you'll end up with a puff of smoke and a useless motor. Okay, you can see the bar in the back of that connector. That's showing that they're all connected inside here, okay? Very important that you do that. Do not, whatever you do, connect them terminate them separately. Okay, all 3 of these must be crimped together. The other ones, these pair, and this pair are 3 of the connections coming from U, V, and W. I'll tell you which ones are which. Okay, but like I say, they'll come through this gland into the box and then connect to these 3. And the 4th cable, which you're probably saying, oh, but there's 4 cables from the motor. That'll get connected to, see this screw down here? That's the earth to the motor. So you unscrew that, and then you put your earth connection, which is coming from here. Let me see, yep, from here. This earth goes from here, out the port, this port here, and then round into the motor, and it gets connected underneath there so that this motor is earthed out. If the motor isn't earthed out, there's a chance you might kill yourself with a massive electric shock. So it's quite a good idea to earth it out. You can use either a forked connector on the end of it, like I have here. I've set these cables up. This earth one here is the one for the motor. Yeah, that'll go under that screw. These other 3 will go into the Wagos. Okay. Into these Wagos that have still got a free port in them, like this orange and yellow and black, for example, and these 2. So, like I mentioned earlier, you've got line 1. I've written it down so that I don't give you duff information. So you get T1 and T7, and that goes to, that's the T1 and the T7 cables here, is connected to the output from the VFD U, which is on the left there. Okay, so that's where T1 and T7 go. T2 and T8 go to the VFD port V, which is the middle one there. Then T3 and T9 go to the VFD port W. And then your earth cable will connect here, as I mentioned, and it'll also connect here. Hope this makes sense to you. I'm trying to make it as idiot-proof as I possibly can, if that makes sense. And then all you do with these cables is, once they're all connected, you tuck them up in there, and then you put the lid of the motor, which has got a rubber seal underneath it, stick that on the top. Be very careful not to catch any cables under here, whatever you do, under the screws or at the lid edges or whatever. Make sure they're well tucked in there, and they're all well secure, because if they're not secured and something's loose, then you know all the pain. And like I say, these things aren't cheap. The motor was $350, that was $350. If you wire it up wrong and blow one of these things up, you're going to be crying for weeks, if you're as tight as me anyway. So that's how it's wired. Hopefully this makes sense. If you've got any questions, put them in the comments and I'll try and address them. Okay. Did I go over the tools that we need? I think I did. Wire stripper, crimps, screwdrivers. Another thing to note, the cables that come out the motor are hugely long, so I've chopped a good, 3 or 4 inches off them. And that's just so that I can get them in there a bit easier without having loads of cable coiled up. I could have taken them even further back, to be honest, probably to nearer where the labels are, you know. I might, I'll see if this fits in okay. If it fits in okay, I'll just leave it at that. If it doesn't, and it's all getting a bit much, I'll chop these back to probably around about here. But yeah, so as I can still read the T numbers, so that I know what's attached to what. Okay. So then this here will get connected to the grinder frame. And I think I've mentioned before how that happens, but just in case you missed it, these 4 bolts here, these 4 holes here, should I say, the motor sits on the other side of that, and the bolts go through here to connect the motor and hold it solidly in place. Now, when you're putting these on, because you're going to have a grinding wheel, and it's going to be fairly close to the metal plate, I'm putting button heads on here, button heads connections. This is them here. So that will give me a little bit more clearance than a normal bolt, hopefully. It's a normal bolt, probably get another couple of mil on there. And that way also the belts won't catch on it. That's what I'm hoping for. Now I've also got my tracking wheel here. This is threaded M12, and I'm going to connect that. This is a tracking wheel here with the spacers. This bolt is not M12, so I've got an M12 bolt in my pocket. I'll use that, but I'll use the spacer. See this spacer here? That's just a standoff, and it's important that you get it right, or it will wreck your bearings, basically. Don't know if you can see in there. You can see it's got a chamfered end on it, on the end nearest the bearing, so that it goes in slightly. Let me just draw you a diagram. Right, diagrammed. This is it looking at it from this side, okay? That's the wheel. So this is the wheel. This part here is the bearing. The lines that I've drawn here and here are the inner part of the bearing that you can just see in there. There's an inner and an outer race. Just beyond the blue bit, that's the inner. That's this part here. Now your spacer, it just sits on the inner. You don't want to make a spacer or put washers in that are going to sit tight to the bearing, because what it'll do is it'll just, as the bearing's turning, it'll just wreck your, it'll just wreck your spacer. and it'll also wreck your bearings because the friction from the heat of this spinning at like 3,000 feet per second or whatever it is. 3,000 feet per minute, 3,000 feet per second. That'd be pretty amazing. It'll wear it out. Okay, that's why the spacer's got a standoff on it, and this chevron part here is just a diagram of the bolt that goes through it. Okay, so very important that your spacer has a standoff. Now, like I say, this bolt's coming out and it's getting replaced with a M12 with the correct thread. This is an M12 bolt as well. It's got a shaft in it, as you can see, and it's just got threads at the end. However, the threads at the end are like an M10 for some reason. I know not why. So I went and bought my grinder frame and I put an M12 on it. So I need to use an M12 bolt. So that's going on as well. And this part here of the motor, once it's connected, you take that plastic cover off. This is your keyway. You may need to remove it to fit the wheel, you may not. I'll show you the wheel that I've got for it. Okay, this is the wheel that I've got. It's a 6-inch wheel. I wasn't after a 6-inch wheel, I was after a 5-inch wheel, but I couldn't find a 5-inch wheel with a 5/8 of an inch shaft, which is what this one has. I mentioned earlier that most of the UK motors have got 24mm shafts. This one's quite small in comparison, but it'll do fine. And what you need to do is get some heat onto this before you fit it. You'll see there that there's a hole that's got a grub screw in it that holds the wheel to the shaft to stop it from spinning off, I guess. You get an Allen key for the grub screw with the wheel, which is nice of them. So what you do is you slacken that grub screw so that there's plenty of clearance in the keyway here. Like I say, warm this up, and then it should, by rights, just fit onto that shaft. Yeah, it'll fit onto the shaft, but I'll do that once the motor is in the grinder. But I'm just showing you it to give you an example of what happens here. It's also, the motor comes, this is Iron Horse motor, came with a base plate, which I didn't need, so I've just undone it and I've left these bolts in it. However, with the motor, you get a little packet, that's in there, of little rubber bungs that fit in the holes. So what I'll probably do is I'll probably fit those rubber bungs if I'm having problems clearancing it with this bolts in place. Yeah, if it's connecting anywhere in the grinder frame, I'll take these bolts out and I'll fit the rubber bungs. Okay, so that's where we're at so far with the old 2x72 scenario. And let me just get that back on there. That'll hopefully help you wire it up if you're in a similar predicament. Okay, important things to remember: make sure your earths are bonded back to the supply. Okay, these are bonded, like I mentioned, even though there's going to be one at this side and one at this side. This is a common connecting earth rail. All the earths are connected through this rail behind it. You'll see that it's made of metal. Yeah, or if you wanted to be sure, you could just put your earth from the motor on the same screw as the earth from the supply. It's up to yourself. But that pretty much covers as much as I can for now with the inverter and the motor. Hopefully it helps you. If it does, put a like down the bottom, I'd appreciate it. And I'll come back once I've wired this up to this, which I've already explained what I'm going to do. You don't need to see me physically doing it, I'm sure. And I might take a video once it's all wired just to show you. And then obviously we'll get this into the motor, this connected, and we'll give it a whirl and see if it's going to turn that spindle, or if it's going to go up in a puff of smoke. I'm joking, hopefully. Okay, thanks for watching. Okay, I've wired up the motor end now, so I've got these 4 they need to go back to the inverter. Okay, and I'll just show you how I've done it. There you go. There's all those cables are clipped together. There's one line, 2 lines, and 3 lines. If you look in the bottom of the box there, you'll see that I've tightened down my earth lead, which is also coming from the inverter. Okay, so the earth lead is earth to the box. Down here, like I say, it gets earth back to the earth bar in the inverter. Okay, so what I'll do now is I will tidy these up a little bit. I'll make sure that they're sitting well below the lid of the box. Then I'll tighten up this nut here on the inside of my can't really see it very well there. Let's see if that's any better. Yeah, tighten up this nut here, which is the inside part of the gland, to this part here, this nut part here. So make sure they're tight. And then what you do is you tighten this up until the cable here doesn't move, and that's you sealed, dust proofed, and ready to rock. Okay, so like I say, I'll just tidy these up, make sure they're in properly, and they're well down into the box, away from harm's way. Like I say, you don't want to be catching these on these edges when you put the lid on the box, example, etc. Okay, so just be careful of that when you're doing this. These Wago connectors are great. You can also use there's like end crimp connectors you get that you twist on. I don't really trust them, to be honest. Or at a push, you can use like block connectors, but make sure that your block connectors are rated for the amperage of your motor, or they'll just melt. Okay, but these work well. Like I say, they're Wago 221s, I think it was I said. Let me just check. Wago 221, 3-port. Okay, I got a packet of them out of Tool Station for about £9. So happy days. So now I'm going to do is I'm going to mount the motor into the frame, take it all out to the garage, and then I will mount this end from the motor into the inverter. And I'll also put my cables from my plug into the inverter before I take it out there, so I've just got the 3 in the right to connect up, plus the earth that I've mentioned numerous times. So hopefully this helps you if you find yourself in the same situation. Right, so I've mounted the motor. You can see the button heads there on the motor. That's face mounting it onto this plate here. Obviously I've got my wheel to go on. I'll just show you this idle wheel. I've mentioned it before, but there is the actual spacer. You can see it's got a stepped end on it. I'll actually need another one for the other side of the wheel, because it's obviously got a bearing in it as well. So I'll need to put another stepped spacer in here. I'll need to figure out the depth of it. It fits in here, screws in there. Obviously the bolt needs to get taken down a bit in size, but I'll just kind of give you the gist of it, you know. Obviously I can't mount it like this because there's nothing stopping it from moving. And then there's a 6mm goes in the back hole here, and what that does is it pushes this out and in so that you can align your belt properly. You know, it should be sort of sitting pretty much horizontal, but sometimes they need to just be adjusted a little bit either way. But I need a spacer for the flipping wheel, which is a bit of a bummer because that's the only thing stopping me. As you can see with the motor, I put the wiring at the back because the whole thing tilts on its side. I also need a 6mm, not an 8mm that I ordered, to fit into that slot. And what that'll do is that'll lock it in position at 90 degrees. Yeah. So when the whole grinder gets tilted over, to 90 degrees. That's stop. We'll stop it from going past 90 degrees if you like. It's obviously past 90 degrees there. You can see. So we want to sit about here, ideally. So, more expense. I've also ordered a longer cable. I'll tell you why. Because the cable for the inverter is only a metre. It's not really long enough to reach the plug without it being like taut, because my plugs are quite high up in the wall compared to where the height of the bench. It was something I never thought about, to be honest. So just need to order more cable and rewire the inverter. These are my tooling arms that I've got. Probably showed them before. That's the platen there. One at the back there. That's the work rest. As you can see, and this one here, this is my new purchase. This is a small wheel attachment. You get various size bobbins that fit in there. They run in bearings into these cups at the edges, so that'll be useful for grinding out like finger reliefs and things on scales, you know. And that bit of aluminium, that's going to be a tilt table. I need a machine. I'm waiting for some more alloy to arrive, and I'll need to machine a block that gets fixed to that, and then I'll have a bar going through it to various other blocks that attach to my tooling arm, and that way it'll allow me to tilt that in any angle I like. But I'll obviously have to drill through the aluminium block for the rod to go through it. I don't know if that makes sense or not. It'd make sense if I showed you it when it was done, and I might just do that. So excuse all the rubbish in the recycling bin, but we're getting there, slowly but surely. Okay, so the 6-inch wheel, the drive wheel's going on. Next, I've just got these two spacers, one on each side, so that when the wheel goes on, we know that it's going on level with the drive output, if you like. And it'll also leave enough to clear this part here, where it's been spaced out 10mm, and also the platen, it's got a 10mm thickness on it as well. So we'll try that. If it's too far out, we can take them out and just chop it down a little bit before we tighten the grub screw. But it should be good to go at that, hopefully. Like I say, wheels in the oven there with the pizza cooking away nicely. Right, so we're making progress now. I've got my motor wired up. I think I already mentioned that anyway. This is the tensioner for the belt, which goes down like so. And I'll try and see if I can just connect it with the tensioner. Give me a sec. Oh, hooray. I did. Okay. Oh, that's nowhere near tensioned enough, I don't think. I think I'm going to need a stronger ram on here, because that ain't going to do it. This is just loose at the minute, because I need to space it out properly and get my bolt in the back, but this is what she looks like. Taking shape. This bar, slightly too long. It's hitting the bolt at the back there. So I'll have to trim maybe 2 or 3 inches off it. Same with the tool rest. It's too long as well, so I'll need to shave some of that off as well. I'll take this belt off because that drive wheel's still hot. This is a wheel that I stuck it in the oven, and then I used that 10mm plates there underneath it, so I didn't push it too far in. And as you can see, it's pretty close to that nut, the dome-headed nut, but it is clearing. So I'll undoubtedly have to do some fettling once I get this actually together properly, and that's just part and parcel of it. But I'll leave it at that just now because I've ordered more cable for my inverter side, and I also have to get this onto a bench. I have to cut down these alloy bars here and the other one, and then hopefully we'll be ready to fire this thing up and see if we can create some sparks. So that's the progress so far. Maybe not as much as I'd have liked to have seen in the last few days, but I've had a bit of a nightmare ordering the wrong size blooming bolts and things like that, you know, and now I'm going to have to go away and order a stronger ram for this as well, so that'll be another delay of God knows how long it takes to get from eBay or land up here, you know. So I'll leave it at that for today. Hopefully the next time we come back we'll be seeing some sparks flying. But that's it for today. Hope you enjoyed it. If you did, stick a like down the bottom. It'll encourage me to make more of these videos. I'll also be making a video when I get round to making my tiltable table, which is what that aluminium there's for. And that might help some people as well, hopefully. But we'll call it a day at that. Quite happy with my progress today. Like I say, it's not complete, and I need to clear some room in the shed to put this on the bench. So I'll come back once that's all done. And like I say, thanks for following. Subscribe up if you're interested in this sort of thing. And stick a like down the bottom, I'd appreciate it. Thanks very much. See you next time.